This is section 10-2, and in this one we're going to talk about strain and deformation in specifics. So strain is the change in shape and or volume of a rock caused by stress. As stress accumulates in a rock, it will begin to undergo strain and it will change shape and or volume. Strain takes place in three stages. Oh, that should be in. So I'm going to draw a little graph because we love graphs. So this side is going to be stress. Increasing, and this side is going to be strain, increasing that way. So stress is the pressure being placed on the rock, strain is the change in shape of the rock. Okay. So what happens at the beginning, this first line, this is elastic deformation right here. So that's your in black. Eventually, you're going to reach the limits of the elasticity of the rock. Then, what's going to happen is that you're going to get ductile deformation. And eventually, the rock can't hold any more energy and it fractures. Fracture is also known as brittle deformation. So in general, as you increase the stress, you're going to increase the strain and you're going to elastically deform. Eventually you're going to reach the limit, then you're going to ductily deform, and eventually you're going to reach the limits of ductile deformation and you're going to fracture and break the rocks. Okay. So now let's go over what each of these terms mean. So elastic deformation. You can think of a rubber band. You stretch a rubber band, you release it, it goes back to its original shape. So elastic deformation changes shape of the rock, but will return back to original shape if stress is removed. So this is not permanent. So basically it changes the shape, but if the stress is removed, it goes back to its original shape. Ductile deformation is also known as plastic deformation, because the ductile and plastic mean very similar things. This is beyond the elastic limit. It will change shape permanently. So once you reach the elastic limit, then you're going to change the shape of the rocks and they're going to stay that way. When the stress is removed, they're not going to return to their original shape because you've gone beyond the elastic limits. The rock can no longer return to its original shape. And then the last one is brittle deformation. And this basically accumulation of strain breaks the rock. and this is also known as fracture. So you're going to break the rock. So you eventually get past the point where you're adding more and more stress, you're changing the shape, eventually the rock can't change anymore or bend anymore, it'll actually fracture and break. So the type of strain experienced is dependent on several things. First thing is temperature. Higher temps cause elastic or ductile deformation. Warm things are a lot more flexible than cold things, so they usually will bend and fold versus break. Lower temps will break. Rocks closer to the surface aren't as hot, because remember the geothermal gradient increases as you go deeper into the earth, but near the surface they're very cool and they have a tendency to break versus behave ductily or elastically. So temperature, confining pressure, same thing. Confining pressure, the more pressure, the more likely they will behave elastically or ductily. That's because, once again, the pressure keeps the rock together. It's not going to allow it to fracture and break. So less pressure, more likely to fracture, same thing. It's closer to the surface. It can actually move and fracture. The next one would be rate of strain. The faster the rate, the more likely rocks will break and behave brittly. And that's because, like, you can think of it as striking with a hammer. You strike with a hammer really quickly, it's accumulating a lot of stress, it's going to break versus fracture. Slower rates, more likely to behave elastically and ductily. Presence of water also influences it. So the presence of water, if water is, or you have a wet rock, so that means water is present, they behave more elastically or ductile. Basically, the water allows slippage to occur, allows it to slip versus break. So dry rocks are more likely to break. And then we have the composition. So the composition of rocks vary significantly. Certain rocks behave brittly. Like limestone, it breaks and fractures very easily because calcite is very brittle, where other rocks that have a lot of muscovites, biotite, clays, and various other minerals will behave more elastically or ductile. Because these minerals are a little bit more flexible, they don't fracture as easily, so it just depends on what the rock is made up of. But it's all these things working together, so it's not just one or the other. All these things work in combination to figure out if rocks are going to behave ductily or brittlely. Temperature and pressure, combining pressure, work together. As rocks get deeper and deeper, they're undergoing higher pressures and higher temps, therefore they behave elastically and ductily, versus near the surface they're going to act brittly because they don't have as much confining pressure and temperature. But it does depend on the type of rock, presence of water, rate of strain, and all these things together.